Today we're talking about solving rational equations. So first thing I ask is, would you rather solve equations with fractions or without fractions? Oh, we gotta look at number 7 from the assignment. Okay, hang on. Okay, so solving equations with fractions or without fractions, me personally, I would much rather solve equations without fractions. And that's what we're looking at today. We have these rational expressions we want to solve for x. So hopefully we can get rid of the fractions completely. And if we do it correctly and we're good at it, we can get rid of those fractions in a hurry. We can solve rational equations by multiplying each side of the equation, like every individual term. So every single expression, right here, that's the key, every single expression, by the least common denominator of all the rational expressions in the equation. That's going to work for every single problem here. So, for example, in example A, I have an x plus 1 in my denominator. I also have a 4x plus 5 in my denominator. So that's what my least common denominator is going to be. It's going to be what's on the left side, x plus 1. What's on the right side, 4x plus 5. If I multiply every single term by that, I can get rid of the fractions. So I'm going to say 3 times x plus 1 times 4x plus 5 all over the x plus 1. All I'm doing right now is I'm multiplying by that least common denominator. 9 times x plus 1 times 4x plus 5 over 4x plus 5. And what's going to happen when I do this, I have, hey, look, an x plus 1 divided by an x plus 1. That's going to go away. Hey, look, a 4x plus 5 divided by 4x plus 5. That's going to go away. So now what I've got is 3 times 4x plus 5 over 9 times x plus 1. And I get 12x plus 15, distribute the 9 on the other side, 9x plus 9. And that is much easier to solve now than what I had before with those fractions and x's in the denominators of fractions. So I subtract 9x from both sides, and I end up getting a 3x plus 15 equals 9. Subtract 15 from both sides, and I get 3x equals negative 6. Finally, I divide both sides by 3, and I get x equals negative 2. And that should be my solution for this problem. When I'm done, it's never a bad thing to go back and check your answer. And the way I do a check is I plug in my result, my negative 2. And I should get the same thing on both sides of the equation. So on the left side, I end up with 3 over negative 1. On the right side, I got 9 over negative 8 plus 5. So 3 over negative 1 is just negative 3. On this side, I get 9 over negative 3. That is negative 3. So that checks out. So that's what I end up getting for my answer here. So negative 3 equals negative 3. So I double checked by plugging the negative 2 back in to verify that I did my work correctly, and it did work out. That's perfect. That's what I'm doing on these types of problems. Let me show you another example. Example B, I'm looking for the least common denominator first. I'll do this one in blue. And I see a 5 in a denominator, and then I see an x in the denominator, so I'm going to do an x. I don't need to do 5 times x times x, I just need to do 5 times x. That'd be my least common denominator. Basically, I'm just looking for whatever's in the denominators. That's what I want to put for my least common denominator. And now, I want to multiply every term individually by that 5x. And so that's where this 5x comes from. 5x, 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 5x. The nice thing about equations, they stay balanced if I do the exact same thing to every value in the equation to both sides of the equation. And that's what I'm doing here. I'm multiplying everything by 5x, so it's keeping the equation the exact same. That's a legal algebra move. But the nice thing about using that common denominator again, I have an x in the denominator and an x in the numerator there that can divide out. On this one, I have a 5 in the numerator and denominator that can divide out. And on the other side of the equation, I have an x in the denominator and the numerator that divide out. So let's write out what we have left after all those fractions kind of go away. I have 15 times 5 plus 4 times x equals 7 times 5. That is a much better equation to deal with than what I had before. 15 times 5, that's 75, plus 4x equals 35. I subtract 75 from both sides, and I get 4x equals negative 40. I divide both sides by 4, and I get x equals negative 10. That's what I get for my result for this problem. All right, that's the idea here. X equals negative 10, looks good. If I want to, I can check. It's never a bad thing to double check our answers. 15 over negative 10 plus 4/5 equals 7 over negative 10. So this becomes negative 15 tenths plus 4/5. I need to get a common denominator there. If I multiply it by 2, I'm going to get 8 tenths. So I get negative 15 plus 8 equals negative 7. And sure enough, negative 15 plus 8 equals negative 7. So I get negative 7 tenths equals negative 7 tenths. So it checks out. So my negative 10 did work as an answer. Double check your answers. That's really important. All right, that's how you can verify you did it correctly. If I got something that was like negative 7 tenths equals 5 tenths, that means I didn't do the work correctly. I need to go back and check my algebra again. So you should always be able to double check your answer and prove that your work is correct. Okay? So there's an example B. Just keep moving on. Example C here. I'm going to just delete this little part here. Example C, 1 minus 8 over x minus 5 equals 3 over x. Let's find that least common denominator. I've got an x on the denominator. I've got an x minus 5 in the denominator. So that would be my least common denominator. Even though I have a 1 here, that's basically like 1 over 1. So I can treat it just like that. Okay. Okay, so what I can do now is I can say x over x minus 5. I can multiply that by every single term. So I have the 1 times x minus 5 minus 8 times x minus 5, but that's over the x minus 5 already, equals 3 times x minus 5 all over x. So again, I'm just, the part that's being added here, x times x minus 5, I'm just multiplying that by each individual term. That's where the x times x minus 5 is coming from. Everything else is from the original equation, 8 over x minus 5. It just looks a little bit different now because of the other part being added. 3 over x. The nice thing though, when I do this correctly, I should get rid of all my denominators. X minus 5's divide out, and on the other side of the equation, x's divide out. So I'm left with x times x minus 5 here, times 1. The second part is 8 times x, and the third part is 3 times x minus 5. All right, not too bad. And now from here, I just need to simplify and solve algebraically. So I'm going to distribute my x there. I'm going to distribute 3 here. I get an x squared minus 5x. I still have that minus 8x. On the other side, I have 3x minus 15. So negative 5x minus 8 more x is going to be negative 13x. And now this looks a little annoying. It's going to be a quadratic problem. X squared minus 13x. So I'm going to get everything on one side of the equation in order to solve this. So I'll start by subtracting 3x from both sides. X squared minus 16x equals negative 15. And then I'm going to add 15 to both sides. Negative x squared minus 16x plus 15 equals 0. And then I would probably need to do a box method for this problem to try and simplify it. X times x. It's a positive 15, so both these terms are going to be negative, and they need to add 16. It turns out this is just going to be 15 and 1. Negative 1x, negative 15x. So this one factors to x minus 15 and x minus 1. So I can have an x minus 15 equals 0, an x minus 1 equals 0, and I get an x equals 15, and I get an x equals 1. And what that means, if I plug in 1 for this equation, or if I plug in 15 for this equation, I should still get a correct answer either way. That's the idea with these problems here. All right. And sure enough, if I plugged in a 1 real quick, I'm going to get like an 8 over negative 4 up here over equals 3. So I get 1 minus 8 fourths. 8 fourths is just, 8 is going to be 2. So I get 1 plus 2, and I get 3 equals 3. So that does check out if I double check my work. I didn't write anything down there. I was just doing it in my head real quick. But we should be able to double check our work, and both of these answers should check out. All right. Any questions on these 3 problems so far? We'll take a look at one more, and then I'm going to let you guys do a little bit of practice. Okay. Last one here, example D. Last one we're going to take a look at together right now. First step, find that least common denominator. But I guess I have to say, hey, this x squared minus 1, I need to simplify that. That's going to be a difference of squares. It's going to be x plus square root of 1, x minus square root of 1, and the square root of 1 is just 1. So starting with, what's my least common denominator? Hey, I see an x minus 1, and there happens to be one over here too. So I'm going to write down an x minus 1. I also have an x plus 1, so I need to write down x plus 1. And that's what my least common denominator is going to be for this problem. Now, I have 7 over x minus 1, and I'm going to multiply by that entire least common denominator, x minus 1, x plus 1. And then minus 5 times x minus 1, x plus 1. 6 over x plus 1 times x minus 1 times x minus 1, x plus 1. All right, that's how I write down this whole thing. It looks like a lot of work, but we gotta show all the steps, so we just gotta write this part down. And now the fun part, let's get rid of those fractions. Hey, there's an x minus 1 and an x minus 1. Let's get rid of those. So we cross off everything we don't need, and then we'll rewrite it a little simpler. So I have a 7 times an x plus 1 left here. I still have a 5 times an x minus 1, x plus 1 equals 6. The whole thing just equals 6 now. That's not too bad. 7 times x plus 1 becomes 7x plus 7. X minus 1 times x plus 1. We actually already know that was x squared minus 1 from being up here. So I'm just going to do that real quick. And then I'll distribute this negative 5 through. It'll make it a little bit easier for me. So I get minus 5x squared plus 5 equals 6. And now I can go ahead and start combining like terms. I'll write the 5x squared first. plus 7x, and then I had 7 plus 5 is 12. And I'm going to subtract 6 from both sides. I get negative 5x squared plus 7x plus 6 equals 0. That's kind of annoying. That's a tough problem. But now, what I can do is I can try the factor box method, or I can try the quadratic formula if I don't want to worry about the factor box method. I'm just going to go ahead and do the quadratic formula because it looks kind of tricky. So remember, quadratic formula is prior knowledge. That's from AGS2. So I need you to show all your work up to this point. But then after that, you can say, hey, I'm going to use the quadratic formula. Just identify your A, B, and C values for me. A equals negative 5, B equals 7, C equals 6. And then I'll just do this by hand, but I don't expect you to show me by hand how to use the quadratic formula at this point in our math careers. So it's x equals negative b plus or minus b squared minus 4ac all over 2a. B is 7. A was negative 5. C was 6. All over 2 times negative 5. Again, I don't expect you guys to do this by hand. I'm just doing it by hand right now because I don't have a calculator easily accessible. 4 times 5 is 20. 20 times 6 is 120. All right. And I'm just simplifying a little bit at a time so that way I make sure I don't make a mistake. So I end up getting negative 7 plus or minus the square root of 169 over negative 10. Lucky for me, square root of 169 is just 13. So this actually is factorable. So if I did a factor box, I would have been able to do this. But it just looks really hard to see with a factor box. But if I took a little bit of time, I might have been able to do that and save myself a little bit of time. So I can write this as two separate equations now. Negative 7 plus 13 over negative 10 and negative 7 minus 13 over negative 10. And I'll get my solutions for x. One of them is negative 20 over negative 10, which is positive 2. The other one is 6 over negative 10, which is negative 3/5. So those look like those are going to be my answers for this problem, my two possible answers. And then I can plug them both back in. They both should work. And I've got my shown work there. All right, now I've just got two problems I want you guys to try now. Find the least common denominator for problems 1 and 2, and then go ahead and solve. All right, try problems 1 and 2. So make sure to check your answers. We should have gotten x equals negative 3 for number 1, and x equals negative 6 for number 2. And remember, you can always plug back in and double check that answer. Any questions on 1 or 2 before we move on to the last couple examples for today? No questions? Okay. Last thing we need to look at today are what's called extraneous solutions. This is why I've been so adamant about just making sure you double check your solutions, because we want to make sure we don't run into what's called an extraneous solution. So what an extraneous solution is, it's a solution that we solve for algebraically but it doesn't work. It doesn't work when we plug it back in. Specifically, it will make the denominator 0. Which is bad. We don't want a denominator of a fraction to equal 0. So let's take a look at something with an extraneous solution here. Sorry, I zoomed in pretty quickly. Let me let you write this down first. Okay. So a good way to think about this is looking at example E here. Just set that denominator equals 0. The first one's x minus 3 equals 0. So I add 3 to both sides, I get x equals 3. So if I solve for this equation and I end up with an x equals 3, that would be an extraneous solution because I would end up with a denominator equals 0 to get 6 divided by 0, which is undefined. So that's why that wouldn't work. On the other side of the equation, I have like an x plus 3 equals 0. And same thing where I subtract 3 from both sides, I get x equals negative 3. So that would be another example of an extraneous solution. So if I get x equals positive 3 or x equals negative 3, I'm going to end up with an extraneous solution for this specific example. Now, just looking at this, I'm going to start by simplifying this part. X plus square root of 9, x minus square root of 9. And square root of 9 happens to be 3. So I get x plus 3, x minus 3. Now I can start by identifying my least common denominator. Okay, I got an x minus 3. Turns out that's going to be in two different fractions, but that's fine. I just have an x minus 3. The other one is x plus 3, also in two different fractions, but I only need to write it down once. So x plus 3 would be my other least common denominator part. Now I can go ahead and multiply everything by that least common denominator. Eight x squared over x plus 3, x minus 3. And then the last part, 4x over x plus 3. And then I have times x minus 3, x plus 3. So there's a lot to write down there, but I should be able to cross some things off. Hey, I have an x minus 3 in the first term. Second term, I actually cross it all off. That's kind of nice. And third one, I'm getting rid of an x plus 3. So now let's go ahead and rewrite it. 6 times x plus 3 equals 8x squared minus 4x times x minus 3. Not bad. I've been able to get rid of a lot of stuff here. So now I end up with 6x plus 18 equals 8x squared minus 4x squared plus 12x. All right, so I get 6x plus 18 equals 4x squared plus 12x. And now I'm just going to need to put everything on one side of the equation together. 18 equals 4x squared plus 6x. Subtract 18 from both sides, I get 0 equals 4x squared plus 6x minus 18.
What happened to the 8x squared?
So the 8x squared, we combined like terms right up here. So we had 8x squared minus 4x squared, so that became a single 4x squared. All right, so I could see that being a little confusing because we ended up with 4x squared still, but it's a different 4x squared than what we had above. So yeah, that's where the 8x squared went. All right. So now I have 4x squared plus 6x minus 18. I'm just going to go ahead and divide both sides by 2. As long as I divide both sides by 2, I'm keeping that equation balanced. And that's going to simplify this a little bit because 0 divided by 2 is still 0. But the other side becomes 2x squared plus 3x minus 9. And now I want to go ahead and see if I can factor that a little bit. I'm going to use the factor box this time instead of quadratic formula. I like dealing with 2's more than 5's and 6's. So I end up with a 2x squared plus 3x minus 9. The factors of 9 would be a minus 3 and a plus 3, because then I'm going to get a positive 6x there and a negative 3x there. That's going to get me a 3x in the middle. That's perfect. So I end up with a 2x minus 3 and x plus 3 equals 0. And now I just solve for each particular equation individually. 2x minus 3 equals 0. X plus 3 equals 0. One of them, I'm going to get x equals negative 3. The other one, I add 3 to both sides. 2x equals 3. Oh, I'm out of room, dang it. X equals 3 halves. So I get an x equals 3 halves. The other one, I have an x equals negative 3, which we talked about at the beginning. If I get a negative 3, that's bad. That means this is an extraneous solution. I solved for it algebraically, but if I plugged that back in at the very start of the equation, I'm going to get a 0 in my denominator, which is really bad. Because then I would have something divided by 0, and I can't do that. So that's an example of how an extraneous solution works. So there were two possible solutions, but only one of them worked. X equals 3 halves. The other one did not work. All right. So that's how we ended up with example E here. All right, a lot of steps when we're solving algebraically, but the key to get it going correctly starts right here, finding that least common denominator at the very top and getting rid of all the fractions. Even though it's still a pain to solve, it's a lot easier to solve without those fractions. Okay, let's look at one more problem here today. This is our last problem of the day. 5x over x minus 2 and 7 plus 10 over x minus 2. Least common denominator, this one's actually not too bad, x minus 2. So I end up with a 5x times x minus 2 over x minus 2. And then on the other side I get 7 times x minus 2. And then plus 10 times x minus 2 over x minus 2. And then I get x minus 2 over x minus 2. Those are going to go away. So I'm left with 5x equals 7 times x minus 2 plus 10. That's not too bad to solve right there. Not too bad at all. And now I end up with, simplifying this, 5x equals 7x minus 14 plus 10. Combine some like terms here. 7x minus 4. Let's go ahead and divide both sides by 7x. And I get negative 2x equals negative 4. Divide both sides by negative 2, and I get x equals 2. So there's my answer. Now when I go back for the check, I plug in 2 everywhere. And what happens? I get a 10 over 0 on the left side and a 10 over 0 on the right side. So this does not work because I have a denominator of 0. So there's only one solution here, and it turns out it's extraneous. So what you do on a quiz or a test, if you have a problem like this, you cross it out, you write down the word extraneous, and then you just write down, hey, there's no solution. So this equation is actually not solvable, example F. There's only one possible solution and it didn't work. So that's the extraneous solution there. Okay.